Previously, we saw that if two matrices are equivalent, we can use this knowledge to write and solve equations. So in this matrix equation, we see the left side is matrix multiplication. So if we were to work out that multiplication, we would see that some of the entries would include variables. And if the right side of that equation has a matrix, we know that the two sides would be equivalent matrices, saying that corresponding entries would also be equivalent. So I could write equations and solve them to find the values of our variables. So let's go ahead and do that matrix multiplication on the left side. So I have a 2 by 2 times a 2 by 2, which is going to give me a 2 by 2. So I'm going to work across the rows and down the columns. So row 1, column 1 will be row 1, column 1. So A, and then negative 2 times negative 6 is plus 12. So that's the entry in row 1, column 1. So let's go to row 1, column 2. Will be across this row and down this column. So 7A, and then negative 2 and 4 makes minus 8. So that's the first row. Let's move down to the second row. So row 2, column 1 will be 2. And then we have this little binomial here, so it'll be minus 6 times the quantity, b plus 1. And then row 2, column 2 will be 2 times 7 is 14 plus, and then 4 times the quantity, b plus 1. And what that equals is this matrix over here on the right side, which will be unchanged. So far we have this for a matrix equation. I bet I can simplify some of this stuff though a little bit. So let me rewrite this. So we have a plus 12 and 7a minus 8. And that's going to equal this side, 17, 27, negative 16, 26. But this stuff can be worked out. I can go ahead and distribute that, 6b minus 6. So then the 2 minus 6 will be a minus 4 minus 6b. And then here we've got 14 plus 4b plus 4. So we could say 4b plus 18. Okay, so I have this 2 by 2 is equivalent to this 2 by 2. So it's interesting to note that I could write 4 equations. A plus 12 equals 17, because the corresponding entries row 1, column 1. I could also say 7a minus 8 equals 27. And if we drop down a little, we could say negative 4 minus 6b equals negative 16. And then 4b plus 18 equals 26. Okay, so the thing worth noting, 4 equations, but only 2 unknowns. So I really only have to do the bare minimum to solve. So if I subtract 12 from both sides, a equals 5. And I bet if I did the same thing over here, just to confirm, 7a equals 35. So again, yeah, a equals 5. So, and it should be the same because they're both a. So this guy, if we subtract 18 over here, we're going to get 4b equals 8. So we divide, b equals 2, which we would get as well here. So let's add 4 to both sides. Negative 6b equals negative 12. b equals 2. So when we have these matrix equations, if we have some multiplication here to do, we're going to go ahead and work that multiplication out, and we're going to get some expressions. And then with these equivalent matrices, we can go ahead and set the corresponding entries equal to one another. Then when we have this nice system of equations, we can just go ahead and solve. So in this case, a is 5 and b is 2.